Hey everyone, welcome back to the Deep Dive. Today we're going deep into the world of data modeling.
Always a fun topic.
We're looking at an article from DataPro.news, 10 ways data modeling can go wrong, and hopefully help all of you avoid those pitfalls.
That's good.
Whether you're, a seasoned data engineer or just starting to explore the field.
Right.
And, data modeling is often one of those things that gets kind of overlooked.
Yeah.
But it really is the foundation, I think, of any data project that you want to really make successful.
It really is. It's that blueprint that kind of sets you up for success so you don't end up with just a big mess of data.
Yeah, exactly. So before we dive into all the things that can go wrong, I think it's helpful to just quickly level set.
Sure.
So what exactly is data modeling? Why is it so crucial?
Well, data modeling is essentially the process of organizing and standardizing data.
Okay.
It's all about creating that structure, that foundation for how your data is going to be structured and used.
Yeah.
And as Dr. Andrew Ng, highlights, it's a core data management discipline that helps organizations really meet their information needs.
So it's not just about the technical specs.
No.
It really does connect back to the business side, the needs there.
Absolutely. It's about understanding the business and what they're trying to achieve with that data, and then you're translating that into a format that can be, worked with.
And so when we talk about data modeling, there are actually different types of data modeling, right?
That's right. We have conceptual, logical, and physical.
All right, so let's break those down, starting with conceptual data modeling. What's the main goal there? What are we trying to achieve?
So with conceptual data modeling, we're really focusing on that big picture.
Okay.
We're trying to identify those key entities, the relationships between them.
Yeah.
And this is done in a way that's technology agnostic at this point.
So we're not getting into the nitty-gritty details of what database we're going to use or
Right.
Any of that stuff.
It's almost like a brainstorming session where we're just sketching out the initial design.
Gotcha. So really understanding the needs more than the specifics of the implementation.
Exactly. And that's why it's so critical to involve all the stakeholders early on in this stage.
Right.
Your business analysts, your data engineers, your end users, everyone needs to have a voice at the table to make sure that that model accurately reflects what the business needs.
Yeah, that makes sense. But even at this early stage, this conceptual data modeling, the article highlights a few potential pitfalls.
Right.
And one that really jumped out at me was starting too late.
Yes.
What kind of consequences can that have?
Well, imagine you're building, let's say, a complex financial data warehouse, and you decide to skip that detailed conceptual model. You could end up with tables and relationships that just don't accurately reflect how transactions actually flow.
Oh, wow.
And that could lead to reporting errors, potentially even regulatory issues.
Yeah, that's a high-stakes mistake.
It is.
So I guess investing the time up front to get that conceptual model right is really, really critical.
It's an investment that will definitely pay off in the long run.
Okay, what about insufficient stakeholder involvement?
Yes.
So we talked about how it's important to get everybody at the table, but why is it so detrimental if we don't have that full participation?
Well, if you don't capture the perspectives of everyone who will be using or impacted by that data model, you risk creating something that's incomplete, inaccurate, or just plain doesn't work.
So it's not just about avoiding technical debt down the line. It's about making sure that the model actually meets everyone's needs.
Exactly. It can even lead to pushback when you try to implement the model if people feel like their needs weren't considered.
Right. It's well, I wasn't consulted on this, so
Exactly.
Why should I buy in?
Exactly.
Okay, so another potential pitfall that the article highlights in this conceptual modeling stage is a lack of clarity. So what are we talking about here, and why is that such a big deal?
Clarity is all about being precise with our language and definitions.
Okay.
For example, if we're defining an entity like customer,
Right.
we need to be crystal clear about what exactly that includes.
Right.
Are we talking about potential customers, former customers, active customers?
Yeah.
Without that clear definition, different teams might interpret it differently.
Right.
And that could lead to inconsistencies and potentially even corrupting your data down the line.
So it's about having a shared understanding across the board
Absolutely.
of what each element represents.
It's really about having a shared vocabulary.
Okay, so once we have that solid, conceptual model in place, we move on to logical data modeling. What What kind of shifts at this stage?
So this is where we start refining that initial sketch, right?
Okay.
So we start adding more detail, more structure.
Right.
We're defining those specific attributes for each entity, outlining the relationships between those entities, and really establishing those rules and constraints that are going to govern our data.
So we're moving from that high-level overview to a more detailed blueprint.
Exactly.
Okay, so what are some of the things that we need to keep in mind as we're working through this logical data modeling phase?
Well, one crucial thing is consistency.
Okay.
And specifically in our naming conventions.
Gotcha.
So using clear and descriptive names for our entities, for our attributes,
Right.
makes that model much easier to understand. For example, if you're using, customer address in one part of the model,
Right.
don't abbreviate it to custad somewhere else.
Yeah.
It might seem like a small thing, but these inconsistencies can cause major headaches later on when you're building queries, integrating data.
It's like good housekeeping, basically, right?
Absolutely. Good data hygiene.
Okay. What else should we be thinking about?
Another thing is granularity. This refers to the level of detail that you're capturing in your model.
Okay.
And you need to strike that balance, right?
Right.
Because if you have too little detail, you might not be able to answer some important business questions.
Sure.
But if you have too much detail, you risk overcomplicating things.
Right.
And impacting performance.
So how do you determine the right level of granularity? Like what's the sweet spot there?
It really comes down to understanding the specific needs of the project.
Sure.
So, for example, if you're building a data warehouse for reporting and analysis, that often needs a high level of granularity to capture all those nuances.
Right.
But a transactional database where speed is key,
Sure.
you might want to have a lower level to
Right.
keep things running smoothly.
So it's context dependent. It depends on what you're building.
Very much so.
What other things should we be thinking about at this logical modeling stage?
And finally, we can't forget to think about the applications that are actually going to be using this data.
Right. So it's not just a theoretical model. We have to think about the practical application.
Absolutely. So imagine you're building a database for, let's say, an e-commerce website,
Okay.
and you haven't factored in the volume of transactions that you're expecting.
Right.
You might end up with a database that's just too slow to handle all that traffic during, peak times.
Yeah.
And that leads to a poor user experience.
Right. Very real business implications.
Absolutely. Lost sales. So we need to think about that logical model as that blueprint for that physical implementation,
Okay.
making sure it aligns with what the application actually needs from the get-go.
So we've moved from conceptual to logical. Now let's talk about the final stage, physical data modeling. What are we doing here?
So this is where we're taking that detailed blueprint from the logical model, and we're actually translating it into the physical database structure. So we're defining the table, the columns, the data types, all the constraints.
So rubber meets the road here. We're going from abstract to concrete.
Exactly.
Exactly. What are some things we need to look out for in this stage?
Well, one common pitfall, and this is something that trips up a lot of people, is mixing up keys and indexes.
Keys and indexes, yeah.
Now, both are important,
Yeah.
but they serve different purposes.
Okay.
A key is what uniquely identifies a record. Think of it like a social security number.
Gotcha.
An index, on the other hand, is what's used to speed up data retrieval.
Okay.
So it's like the index at the back of a book, right? Helps you find information quickly.
Yeah, okay.
And using one in place of the other can lead to duplicate records, slow queries, or just bloated databases.
So it's really important to understand those nuances and use them correctly.
Absolutely. Absolutely.
What about mapping UI elements to data fields? Is that a pitfall we should be aware of?
Yeah, that's another one that we need to be cautious about. It might seem convenient at first, right? To just directly map those fields one-to-one.
Sure.
But it creates a very inflexible model. What happens when the UI changes?
Right.
Or you need to add new functionality?
Yeah, you're stuck.
You're stuck with a model that can't keep up.
Gotcha.
So, for example, if you have separate fields in your CRM for, let's say, customer address and billing address.
Right.
And you map those directly to the database,
Yeah.
you're going to end up storing the same address twice if they're the same.
Right. And what if one changes but the other doesn't? And...
Exactly. So it's about thinking about that data in a more structured and relational way rather than just mimicking the UI.
Okay, that makes sense. And finally, we can't forget about planning for data model evolution, right?
Absolutely.
Because data needs change over time.
They always do. And
Yeah.
our models need to be able to adapt.
So it's like future-proofing our database.
Exactly.
What are some ways that we can make sure that we're building in that flexibility?
So choosing flexible data types.
Okay.
Avoiding unnecessary constraints, designing for scalability. These are all great starting points, and of course, thorough documentation is always your friend.
Right, right.
It makes it much easier to understand and modify the model later on.
Okay, so it sounds like physical data modeling requires a lot of, careful planning and foresight
It does.
to make sure that our database can stand the test of time.
Absolutely. It's where all those considerations from the previous stages really come together.
It's amazing how each stage really builds on the previous one.
It is.
And it's creating this comprehensive roadmap for our data.
It's like a chain, right? Each link is important.
Yeah.
But, something the article mentions is that one critical mistake that can happen across all three of these stages is mixing them up.
Mixing them up. What exactly does that mean?
Yeah.
And why is that a problem?
It's so tempting to jump ahead.
Yeah.
Especially with some of those visual tools that, can kind of blur the lines between conceptual, logical, and physical models. But it's really crucial to stick to the right level of detail for each stage.
So don't try to get too fancy too early.
Exactly.
Okay, why is that so detrimental?
Well, because the conceptual stage is all about exploration, right? It's about getting everybody on the same page.
Sure.
And if we jump ahead to those logical or physical stages too soon, we risk stifling that creativity.
Okay.
We lock ourselves into a design before we've fully explored all those possibilities.
So it's about maintaining that fluidity, that openness to feedback in the early stages.
Exactly. And Kurt Cagle, in his article on data modeling mistakes, he really talks about that the conceptual model needs to be fluid, allow for that input, be a basis for experimentation. You want to see what breaks before you build the whole thing.
Right. Yeah, that makes sense.
Okay.
So don't rush the process.
Absolutely.
Take the time to explore those ideas, get everyone aligned before diving into the very specific details. Okay, so we've talked about these different stages of data modeling, but now let's dive into those 10 specific ways that data modeling can go wrong. I mean, we've touched on a few of them already, but let's break them down individually.
Yeah, let's unpack those pitfalls. Let's unpack those pitfalls and really understand why they can derail data projects.
I'm good.
We've already discussed starting too late in the conceptual data modeling phase and why that's a recipe for disaster.
Right.
But let's explore those consequences further.
Okay.
So imagine you're building a complex software application.
Okay.
And the development team starts coding before they have a clear understanding of the data requirements.
Right.
They might build features that don't align with the business goals.
Right.
The data structures could be inefficient or difficult to maintain.
Yeah.
It's not just wasted time and effort.
Yeah.
It can really impact the functionality and usability of that final product.
And probably lead to, costly rework later on.
Absolutely.
Much better to get it right up front.
Exactly. And as the article highlights, starting late in that conceptual modeling phase can lead to significant delays in the project timeline.
Okay.
And even jeopardize the project's success.
So it's not a minor oversight. It can have a real cascading effect.
Big impact, yeah.
Okay, so let's move on to the next pitfall.
Sure.
Insufficient stakeholder involvement in that conceptual data modeling. We touched on this earlier, but let's dive a little deeper. Why is it so important to get everyone involved who's going to be impacted by this data model?
Think about it like designing a house.
Okay.
But you only consult with the architect and the builder. You might end up with this beautiful structure.
Right.
But it doesn't actually meet the needs of the people who are going to live there.
Yeah, it's not functional.
It's not functional, exactly. And the same applies to data models. If we fail to involve stakeholders from different departments, we might end up with a model that is, incomplete, inaccurate, or just not useful.
Can you give me a concrete example of how that might play out?
Sure. Imagine you're building a data warehouse for a retail company.
Okay.
But you don't involve the marketing team.
Right.
You might end up with a model that doesn't capture the data they need to analyze customer behavior or track marketing campaigns.
So it's really about making sure that the data model reflects those real-world requirements.
Exactly, exactly. And insufficient stakeholder involvement can also lead to just cultural resistance.
Right, like, well, I wasn't consulted on this, so I don't.
Exactly. Adoption challenges. If people feel like their needs weren't considered during that design phase, they're less likely to embrace the new system.
It's about building a data model that people understand, trust, are willing to use.
And will actually use, yeah.
Okay. So the next pitfall on the list is a lack of clarity in the conceptual data modeling.
Yes.
And we talked about this a little bit earlier, but I want to dig a little deeper here. What are the potential consequences of not being really clear about, how we're defining these entities and relationships?
Imagine you're looking at a house blueprint.
Okay.
But the labels are vague, the lines are blurry, the symbols are confusing. It would be nearly impossible to build that house correctly.
So clarity is really important, right, to make sure everyone's on the same page.
Absolutely. A lack of clarity can lead to misunderstandings, misinterpretations, incorrect data structures, redundant data,
Wow.
even data integrity issues.
Okay, give me some examples of, how a lack of clarity could impact a data project.
Let's say you're defining the customer entity,
Right.
but you don't clearly define what constitutes a customer, right?
Right.
Does it include potential customers?
Former customers, yeah.
Without that clear definition, different teams might interpret it differently, leading to inconsistencies and errors in the data.
Okay, so being very precise with our language, our definitions, making sure everyone understands the core concepts in the same way.
It's all about having that shared understanding, that shared vocabulary.
Okay, so we've talked about these conceptual data modeling pitfalls. Now let's shift our focus to logical data modeling.
Sure.
And, explore some of the common pitfalls there. We talked about consistent naming conventions.
Right.
Why is that so important in logical data modeling?
Think back to that blueprint analogy.
Okay.
But this time the architect is using different names for the same thing.
Okay.
In different parts of the plan. So the living room might be labeled as the family room or the lounge. It would be very confusing, right?
Yeah.
So consistent naming in data modeling is all about making that model easier to understand and work with.
Makes sense.
So inconsistent naming patterns can lead to all sorts of problems, from misunderstandings between developers to errors in data mapping and integration.
Okay, can you give me some examples of how this might play out in a real project?
Sure, let's say you have a field called customer address, but in one part of the model, it's abbreviated as custard.
Right.
And in another part, it's customer location.
Yeah.
Now imagine you're writing a query to retrieve all customers in a particular city.
Right.
If you're not aware of these different naming conventions, you might miss out on some relevant data,
Right.
end up with incomplete or inaccurate results.
It's fascinating how those seemingly small things
These seem small.
can really have a big impact.
Absolutely.
Okay, so consistent naming is a must. What other pitfalls do we need to watch out for in this logical data modeling stage?
Another common mistake is getting that granularity wrong.
Okay, so we touched on that a little bit earlier.
We did.
But it's worth revisiting because it is so crucial.
It is.
So just to remind everyone, what do we mean when we talk about granularity and why is it so important to get it right?
Granularity is about that level of detail that we capture in our data model. So imagine zooming in and out of a map, right?
Yeah.
High granularity is like zooming in close. You see every street, every building.
Right.
Low granularity is like zooming out. You just see the major highways and cities.
Okay, so how do we know what level of granularity is appropriate? Like, how do we find that sweet spot?
It depends on the specific needs of your project.
Okay.
So if you're building a data warehouse for reporting and analysis, you might need that high level of granularity to capture all those details.
Okay.
But if you're building a transactional database where speed is key, you might opt for a lower level to keep the database size manageable.
So it's that balance between having enough detail but not overcomplicating it.
Exactly. Getting that granularity wrong can lead to a model that's either too simplistic or too complex.
And what are the consequences of getting it wrong?
Well, let's say you're tracking customer orders, but your model is too simple and it doesn't capture the individual items in each order. You wouldn't be able to analyze sales trends for specific products.
Yeah.
On the other hand, if your model is too complex, it can be a nightmare to understand, to maintain, to query, and that can lead to performance issues.
So finding that sweet spot is really key.
It's about finding that balance, yeah.
Okay. We've covered inconsistent naming. We've talked about granularity. Any other common pitfalls we need to be aware of in this logical data modeling stage?
Yes. One that often gets overlooked is not considering application usage in the logical data modeling.
Okay, I'm intrigued. What does that mean?
It's not enough for the model to make sense in isolation,
Uh-huh.
right? We have to think about how that data is going to be used by the applications that are actually going to be accessing it.
So thinking about it in terms of its real-world application, not just
Exactly.
the theory.
Remember, this model is the blueprint for our physical database, and if we don't align it with the needs of the applications, we're setting ourselves up for trouble.
What kind of trouble are we talking about here? What kind of problems can arise?
Well, you could have performance issues, right? If the data model isn't optimized for the queries that the application's going to run,
Right.
you're going to see slow query times,
Yes.
which impacts the entire application's performance.
It's like we built a house, but on like a shaky foundation.
Exactly, exactly. And not considering that application usage can also lead to data integrity issues. If the model doesn't enforce the necessary constraints and rules, you're opening the door to inconsistencies and errors in the data.
Okay.
And finally, it can make scaling the system really difficult as your needs grow.
Gotcha. So can you give me like a concrete example of how this might play out?
Sure, imagine you're building a database for a busy e-commerce website.
Okay.
But you didn't consider the expected volume of transactions or the types of queries that the website's going to be running.
Right.
You could end up with a database that's so slow and inefficient that it impacts the user experience,
Right.
leads to lost sales, and even damages the brand reputation.
Yeah. So really, really critical to think about those real-world implications.
Absolutely, and it really emphasizes the need for that open communication between the data modelers and the application developers.
Right. Working together, understanding each other's needs.
It's a team effort.
Yeah. Okay. So I think we've covered a lot of ground here in this logical data modeling phase.
We have.
We talked about inconsistent naming, incorrect granularity,
Yes.
and this crucial aspect of aligning the model with application usage. Really a critical stage.
It sets the stage for everything that follows.
Exactly. So now let's move on to that final stage of data modeling, physical data modeling,
Okay.
and talk about the pitfalls of actually translating that logical blueprint into a real database structure.
Sounds good.
Let's uncover some of those common mistakes that can trip us up in this final phase.
All right, so we'll start by revisiting a pitfall we touched upon earlier, which is not separating keys from indexes in physical data modeling.
Right.
Really understanding the distinctions between those two and why using one in place of the other can be problematic.
Okay, so remind me again, what are keys and indexes?
Sure.
And why are they both important?
So a key is a special column or set of columns that uniquely identifies a record in a table.
Yep.
Think of it like a social security number, right? It's a unique identifier.
Okay.
And in a database, keys are used to ensure that each record can be accessed and retrieved quickly and accurately.
So very important for data integrity. What about indexes?
An index is a data structure that improves the speed of data retrieval.
Okay.
So think of it like the index at the back of a book, right?
Yeah.
Helps you find the information you need quickly without reading the entire book.
Gotcha.
An index allows the database to quickly find the data you're looking for without scanning every single row in a table.
Okay, so both are about accuracy and efficiency,
Yes.
but they work in different ways.
Exactly. They serve different purposes.
Okay, so what happens when we get them mixed up?
Well, if you try to use an index as a key, you might end up with duplicate records in your table, leading to inconsistencies and errors. It's like having two people with the same social security number. It creates confusion and potential for errors.
Yeah, that's a good analogy. What about using a key as an index?
That can lead to inefficient query performance. While keys ensure that each record is accessible, they might not be optimized for the specific types of queries that your application is going to be running. Indexes, on the other hand, are designed specifically to speed up certain types of queries.
So it's like trying to find a specific word in a book by using the table of contents.
Right, yeah,
It might tell you what chapter it's in,
right.
but you still got to read the whole chapter to find it.
Exactly.
Whereas an index would tell you exactly what page to go to.
Precisely.
Yeah.
Confusing keys and indexes can also lead to increased storage requirements because indexes do take up space in the database.
So it's really important to understand when to use each one.
It is the right tool for the right job.
Absolutely. Okay, so let's move on to another pitfall that we touched on earlier, and that's rigidly mapping UI elements to data fields in this physical data modeling stage. Yes.
So why is this particularly problematic in physical data modeling?
In physical data modeling, we're making those concrete decisions about how the data is going to be stored.
Right.
If we rigidly map UI elements to data fields,
Hmm.
we're essentially locking ourselves into a structure that may not be the best for the long term.
Okay, so for example, if we're building a database for a CRM system,
Right.
and we just directly map the fields in the user interface to the database columns.
Right.
What's the problem with that?
Well, what happens if the business requirements change and you need to add a new field to the CRM?
We're going to have to go back and change the database structure,
Exactly.
which could be time-consuming and potentially cause errors.
It can be a real pain, yeah.
Okay, so it's all about building in that flexibility, knowing that things are going to change.
Things are always changing.
Yeah.
And that rigid mapping can also lead to data redundancy and inconsistencies.
Okay, how so?
So let's say your CRM has a field for customer address
Right.
and a separate field for billing address.
Okay, if you map those directly, you're going to store the same address twice if they're the same.
Oh, okay, yeah.
Not only is that a waste of storage space, but it also creates potential for inconsistencies if those two addresses are ever updated differently.
So it's about efficiency and data integrity.
Exactly, exactly. Instead of that one-to-one mapping, we need to think about the data in a more structured, relational way.
So, for example, we might have a separate table for addresses.
Right.
And then just link that to the customer table.
Exactly. That's a much better approach. It provides more flexibility, reduces that redundancy, and makes that data model much more adaptable.
So it's a much more robust approach.
It is.
Okay, and then the final pitfall on our list is failing to plan for data model evolution
Yeah.
in this physical data modeling. And we've talked about this in previous stages, but why is it so critical in this physical data modeling phase?
Remember, in physical data modeling, we're making those concrete decisions about the database structure,
Okay.
the data types, the constraints, the indexes. These choices have a direct impact on the database performance, scalability, and maintainability.
So if we don't plan for change,
Yeah.
we're going to have a real mess on our hands later on.
It can make modifications really difficult.
What kind of problems can we run into if we don't plan for this evolution?
Well, you might end up with data inconsistencies, right?
Oh,
If
sure.
the model isn't designed to accommodate new types of data or changes to existing data,
Right.
you might encounter performance issues as the volume of data grows, especially if the database wasn't designed to scale.
Right.
And making changes to a rigid data model can become this really complex and time-consuming maintenance headache.
So it's like building a house
Exactly.
without considering the fact that you might want to add on a room later or
Right.
expand the kitchen
A
or,
perfect analogy.
things like that.
Yeah, you got to think about the future.
So what are some practical steps we can take to plan for this evolution?
So, choosing flexible data types, avoiding unnecessary constraints, designing for scalability, these are all really important.
Can you give me an example of like a flexible data type and why that's important?
Sure, let's say you have a field for storing customer phone numbers.
Okay.
You might be tempted to choose a data type that only allows a specific format, like 10 digits.
Right.
But what happens if you start getting international customers with different phone number formats?
Yeah, I got to change it.
You have to go back and modify that data type, and it can be a real hassle.
So thinking ahead and choosing a flexible data type to begin with.
Exactly. It's all about anticipating those potential changes. And the same principle applies to constraints, right? Avoid imposing restrictions that might limit your flexibility later on.
Like, for example.
So let's say you have a field for storing customer names, and you set a constraint that limits the length of the name to 50 characters.
Okay.
That might seem reasonable now, but what happens if you start getting customers with really long names? You're going to have to either truncate those names or go back and modify that constraint.
Right. So it's all about thinking ahead, planning for those changes.
Absolutely. And when we talk about designing for scalability, we're talking about choosing database technologies and architectures that can handle growing data volumes without sacrificing performance.
So knowing that our needs are going to change,
Right.
our data is going to grow, and choosing solutions that can grow with us.
Exactly. And of course, thorough documentation will make it much easier to understand that model and modify it later on.
Yeah. Yeah. Good documentation is always helpful.
It's a gift to your future self.
It really is. It really is. Okay, so we've covered 4 major pitfalls here in physical data modeling. Not separating keys from indexes, rigidly mapping UI elements to data fields, failing to plan for that evolution.
Right.
And of course, that overarching mistake of mixing up the models.
Right. Those stages.
Yeah.
We've got to keep them separate.
Exactly. So I think we've covered a lot of ground here today.
We have. We've gone through a lot.
we've talked about those conceptual, those logical, and those physical stages of data modeling.
Mm-hmm.
And we've talked about a lot of things that can go wrong.
We have a lot of pitfalls to watch out
A
for.
lot of pitfalls, but also, I think, a lot of really good insights.
Absolutely. A lot to learn from those mistakes.
So as we start to wrap up this discussion, let's take a step back and look at those 10 ways data modeling can go wrong. Are there any common threads that run through these pitfalls? Are there any kind of key takeaways that we can leave our listeners with?
Definitely, one overarching takeaway is the importance of communication
Okay.
and collaboration throughout that data modeling process, whether we're working on the conceptual, the logical, or the physical model
Yeah.
involving those stakeholders,
Right.
documenting our decisions clearly, considering the impact on the entire system is crucial.
So it's not a solo endeavor.
It's not. It's a team sport.
It's a team sport, exactly.
Yeah.
Any other key takeaways that come to mind?
Another key takeaway is that data modeling is an iterative process.
Okay.
It's not about getting everything perfect on the first try.
Yeah.
It's about starting with that solid foundation, testing those assumptions, gathering feedback, and refining the model over time.
Which, that actually reminds me of that article we mentioned earlier by Kurt Cagle.
Yes.
Where he talked about the conceptual model needing to be fluid, open to experimentation.
Exactly. He warned against jumping into those complex diagramming tools and drawing boxes before you've really thought things through.
So better to embrace a little bit of that initial messiness.
It's okay to be messy at first.
And let the model kind of evolve organically.
Let it breathe. Yeah.
Okay. Now, before we wrap up completely, I want to go back to the idea of mixing up the conceptual, logical, and physical models.
Okay.
We've talked about this throughout this whole discussion.
We have.
But, for me, I'm still not 100% clear on why that separation is so critical.
Okay, so think about it this way. Each stage in the data modeling process has a unique purpose.
Okay.
And requires a different level of detail.
Okay, so walk me through it. What's the focus of that conceptual stage again?
So in the conceptual stage, it's all about the big picture.
Okay.
Identifying those key entities and relationships in a way that's free from any specific technology.
So like that initial sketch of the house where we're thinking about,
exactly.
The purpose and the layout, not necessarily the plumbing and the wiring.
Precisely.
Okay, and then we move into the logical stage. What are we doing there?
We're refining those initial concepts.
Okay.
Adding more detail, more structure.
Right.
Defining those attributes, those relationships, those constraints.
So it's like going from that initial sketch to a more detailed blueprint.
Exactly.
Okay, and then finally the physical model.
The physical model is where we're taking that blueprint and we're translating it into the actual database structure.
Right.
Specifying all those nitty-gritty details.
So that's like the construction phase where we're actually like building the house.
Exactly.
Okay, so if we start mixing those stages, if we're trying to use a physical modeling tool to do a conceptual model,
right.
What's the problem there?
We risk getting bogged down in those technical details before we've even fully explored the problem.
So it's like designing the plumbing system.
Exact.
Before we've even decided how many bathrooms we want.
Precisely. Yeah. Or if we try to jump straight from that conceptual model to the physical model, we might miss out on crucial details that need to be addressed in the logical modeling phase.
Right. So it's like trying to build a house without a blueprint.
Exactly. Recipe for disaster.
Yeah, definitely.
So keeping those stages distinct allows us to approach the data modeling process in a structured and systematic way. It's about thinking through that problem carefully and not rushing to the finish line.
So it's not just about avoiding mistakes. It's about making sure we thought through everything thoroughly.
Absolutely. It's about being comprehensive.
Okay, so to recap these 10 pitfalls and their implications, it seems like, data modeling, it's not a one-size-fits-all process.
It's not.
The best approach really depends on the data.
Right.
The needs of the business, the technologies involved.
It's about understanding those principles and then applying them thoughtfully to each situation.
And remembering that it's iterative, right? It's not
about perfection.
Perfection, yeah.
It's about starting with a solid foundation and then refining.
So it's a journey of continuous learning and improvement.
Absolutely. And never forget that data modeling is a team sport.
It's a team sport, right? Communicate, collaborate, be open to different perspectives.
Exactly. Work together.
Okay, so as we wrap up here, what's one final thought-provoking question that we can leave our listeners with? Something to kind of ponder as they finish listening to this episode.
We've talked about choosing the right type of model for each stage. But what about the tools that we use to create these models?
Oh, yeah.
How do we know we're using the right tools? And how can we use them effectively to improve our data modeling process?
That's a great question, yeah. We talked about, not jumping into those complex diagramming tools too early.
Right.
But I'm curious, what other tools are out there that can help, streamline and enhance our data modeling efforts?
There are a lot of tools out there, from specialized diagramming tools that can help visualize those complex relationships
Oh,
to collaborative platforms that allow teams to work together seamlessly.
so it's about finding the tools that fit our workflow
Exactly.
and our project needs.
It's not about using the most powerful tool.
Right.
It's about using the right tool for the job.
Right.
And as the field continues to evolve, we can expect to see even more innovative tools emerge.
So it's an exciting time
It is.
to be in this field
It really is.
because these tools are going to keep getting better
Absolutely.
and help us build even better data models.
Exactly. The future is bright for data modeling.
All right, so as we conclude this deep dive, it seems like the key takeaway here is that data modeling, it's a continuous journey.
It is.
It's a journey of learning, experimentation, refinement,
It's a process. It's ongoing.
and by understanding those principles,
Yeah.
avoiding those common pitfalls, and embracing that collaborative, iterative approach,
Yes.
we can create data models that really empower our organizations to thrive.
Well said. Well said.
Thanks for joining us on this deep dive. We hope you found it insightful and you're ready to tackle your next data project with confidence.
Yeah, it sounds like having the right tools in our data modeling toolkit can make a world of difference.
Absolutely. Choosing the right tools can streamline the process, improve accuracy, and ultimately lead to better data models.
So let's talk about some of those tools. What are some examples and how can they help us?
Well, we have visual diagramming tools, for example.
These tools can help us visualize those complex relationships between entities and attributes. It's one thing to describe those relationships in words,
Yeah,
but being able to see them visually can be incredibly powerful.
right. Especially when you're trying to communicate those relationships to stakeholders who might not be as technical.
Exactly. Visualizations can help bridge that communication gap and make those complex concepts much easier to grasp. Then we have data modeling tools that can actually help you generate SQL code directly from your models.
Wow, that sounds incredibly helpful.
They can save you a ton of time and effort, especially when you're working with large and complex models.
Okay, so that's streamlining the development process.
Yeah.
What other tools are out there?
Well, and then of course we have collaborative platforms that allow teams to work on models together in real time.
Oh yeah, that's game changer.
Absolutely. Instead of emailing spreadsheets back and forth, everyone can be working on the same model at the same time, seeing each other's changes and providing feedback in real time.
It's amazing how technology has really transformed the way we approach data modeling.
It's an exciting time to be in this field. As data modeling continues to evolve, we can expect to see even more innovative tools and technologies emerge. Tools that further empower us to build better data systems.
It sounds like it's not just about mastering those concepts and avoiding those pitfalls. It's also about embracing the right tools to make our jobs easier and our models even more effective.
That's a great way to put it. The right tools, combined with a solid understanding of the principles and a collaborative approach, can really take our data modeling to the next level.
Well, as we conclude this deep dive, I'm left with a sense of, awe maybe, at both the complexity and the potential of data modeling.
It's definitely a challenging field, no doubt about it, but the rewards can be immense.
Absolutely. By investing the time and effort to build well-designed data models, we lay the foundation for better decision-making, improved efficiency, and ultimately greater success for our organizations.
Well said. Data models are more than just technical artifacts. They're the blueprints that help us understand and utilize the vast amounts of data that flow through our world.
And by embracing those principles we've discussed today, we can unlock the true power of data and turn it into actionable insights that drive positive change.
Data modeling might not always be glamorous, but it's an absolutely essential discipline for anyone working with data in today's world.
It's like the unsung hero of the data revolution.
I like that. The unsung hero indeed.
Well, thank you so much for joining us on this deep dive into the world of data modeling. We hope you found it insightful, and we encourage you to keep exploring this fascinating field.
It's been a pleasure sharing this journey with you and our listeners.
And to our listeners, thank you for tuning in to The Deep Dive. We'll see you next time for another deep dive into a topic that matters.